Hello. So I'm not able to be in class with you today due to me not feeling well. You can probably tell by the sound of my voice. But I'm going to go ahead and go over and post these notes for order of operations. This is section 1.3. We actually started part of it on Friday. We got through the, oh no, we got through the exponential notation, which is the repeated multiplication, and we got through the simplifying square roots, okay? And so now we just need to go ahead and look at order of operations. So let's get to it. So here's what the order of operations are, why they exist. If I give you two problems, let's say I have 20 minus 12 divided by 4 times 2. Okay. And let's say there were no convention for how people solved these. People could do whatever they would like. Let's see what would happen. Let's say this first person decides that they want to just solve it from left to right, not even paying attention to what's coming, what operations they are, just go from left to right. So here they would do 20 minus 12, which is 8 divided by 4 times 2, and then they get 8 divided by 4, which is 2 times 2, and so they get this is equal to 4. Whereas somebody else doing the same problem, if they followed the order of operations, here they'd get 20 minus 3 times 2, and so 20 or 3 times 2 is 6, so we get 20 minus 6, and here you get a solution or evaluate it and get 14. There's a big difference between 4 and 14. So what if two different banks calculated these kinds of expressions differently? One bank would say that you have $4 and one bank says that you have $14. That'd be a big problem. It would kind of crash our entire financial system. And so we don't let people do things willy-nilly, however they feel like, okay? We follow a convention called the order of operations. A convention is essentially kind of like a generic or general rule of thumb that everyone follows. It's kind of like how we drive on the right-hand side of the road in the United States of America. So to prevent accidents, I mean, it's not perfect, but it helps that people aren't driving head-on into each other. So we follow order of operations as a mathematical convention. It's almost like a language that we follow as well. Essentially, the order of operations tells us the order in which we perform operations when we evaluate expressions. So anytime you see the word evaluate, this should set off a beacon in your brain saying order of operations. Okay? Order of operations, we always start with parentheses. Okay? That's anything that's grouped together in any grouping symbol. So that could be parentheses, it could be brackets, it could be operations inside of absolute value symbols, and it's the numerator. If you have expressions in the numerator and the expressions in the denominator, these are grouped together and the denominators are grouped together. Okay. E stands for exponents, but it also includes any square roots. Okay, so exponents and square roots happen at the same time. The M is for multiplication and D is for division. These happen at the same time from left to right. And A is for addition and S is for subtraction. So you might have learned PEMDAS, either horizontally or vertically. I sometimes draw it vertically so that I can explicitly show that multiplication and division happen at the same time from left to right, and addition and subtraction happen at the same time from left to right. Okay. You might have learned, please excuse my dear Aunt Sally. If you are from a different country, you might have learned it a different way. I know for a fact that in England, they use BIDMOS because they, instead of parentheses, they say brackets for grouping. Instead of exponents, they say indices, I. And then they do D before the M because it doesn't matter because they happen at the same time from left to right. So if you learn this somewhere else, that's perfectly fine. You just need to make sure that you follow the order of operations. again, you could do bid mas. Okay, again, division and multiplication happen at the same time from left to right. So do addition and subtraction. Okay, all right. The other thing to note, a little side note right here, is that when we have exponents, the exponent only applies to the thing that it's directly next to. Okay, so in this first example, the exponent only applies to the 5, but here the exponent applies to the grouping 3 times 5. So here, following the order of operations, you would evaluate your exponent first. So 5 squared is 25. Then you would do your multiplication. 3 times 25 is 75. Whereas here, you would do your parentheses first. 3 times 5 is 15. And then you would evaluate your exponent. 15 squared is 225. Okay, so just be careful with exponents and where what is actually being applied to. So let's take a look at some examples. Sorry about that. The first example, 5a, we have 25 minus 12 divided by 3 times 4. Following our order of operations, there are no parentheses, so I'm going to write it out. Again, I'm going to put boxes around these. There's no parentheses, there's no exponents, so I'm going to do my multiplication and division from left to right. So the first thing I'm going to do is this division. So I have 25 minus, well, 12 divided by 3 is 4 times 4. So essentially, I perform the operation and then bring everything else down. Okay. Then we have multiplication, 4 times 4. So I'm going to have 25 minus 16. And then I will perform that subtraction. 25 minus 16 is 9. For B, I'm going to go ahead and evaluate my absolute value. And underneath the radical, that radicand, I need to simplify that as well because it's grouped together under the radical symbol. So here I'm going to have, I'll go ahead and do that first. Square root of 16 plus 9 is 25. So that division, I'm going to do this in 2 steps so you can see it clearly. I'm going to evaluate my absolute value. So I get 6 minus the absolute value of negative 30 is 30, divided by the square root of 25. Next is exponents. Exponents also mean square roots. So I'm going to do square root of 25, which is 5. So 6 minus 30 divided by 5. 30 divided by 5 is 6, so I get 6 minus 6. So this equals 0. Okay, so the next one, we have 2 open bracket 17 minus 5 times open bracket 6 minus 4 close bracket. Okay, that's the fun way to say that. When we have brackets and parentheses, we kind of treat this like, do this, if it were like Russian nesting dolls, you want to start with the smallest one. So we want the smallest grouping inside of the other grouping. So we're going to go ahead and perform this 6 minus 4 first. So 6 minus 4 is 2 because it was in parentheses. I'm going to leave it in those parentheses. Technically, we've cleared them, but I'm leaving it like that so we can see that we need to do multiplication between 5 times 2. I do that so that I don't accidentally think that it's 52. It's not. It's anytime you have a number next to a grouping that's implied that it's being multiplied by it. So here I'd have 5 times 2 in the parentheses or in those brackets. So in the brackets, I still need to follow the order of operations before I can move to the outside of them. So I have 17 minus 5 times 2 in the brackets. So I'm going to do my multiplication before the subtraction. So that gives me 17 minus 10, still in the brackets, times 2. And then here we'll complete the operations in those brackets. So I get 17 minus 10, which is 7. So 2 times 7 is 14. For D, we are going to start with parentheses or anything that's grouped together. So that's going to be the grouping underneath the radical. So here we will have square root of 25. We have the 3 on the outside there. Bring everything else down. Then we're going to evaluate exponents. So I'm going to do both at the same time. So 2 of them, because we have an exponent and a square root. So that's going to be 5 times 2 squared is 4, plus 3 times square root of 25 is 5. Now we're going to do our multiplication. We have 2 multiplication pieces. 5 times 4. Remember, we do it in order from left to right. So that's going to be 20 plus 3 times 5. And 3 times 5 is 15. So I get 20 plus 15. And the last operation is to add those together, which is 35. Okay, so for this last one, for E, I have 81 times 2 minus 4 times 3 over 5 squared minus 10. Remember, this division symbol groups the top together and groups the bottom together. So technically, we need to perform the operations that are grouped together first. So we have 81 times 2 minus 4 times 3 over 5 squared minus 10. You can pick which one you want to do first. I'm going to go ahead and do the top first. So in the top, we have multiplication. I'm going to perform both multiplications at the same time. I'm going to perform it from left to right. So I'm going to do 81 times 2 first, which gives me 162, minus the 4 times 3, which is 12, over 5 squared minus 10. And then here, I'm going to do the 162 minus 12, because that's still grouped together. So that gives me 150 over 5 squared minus 10. And now I'm going to do the denominator. So I still have 150 in the top, and 5 squared minus 10, I have an exponent. So I'm going to perform that first. So that gives me 25 minus 10, and then do the subtraction. 25 minus 10 is 15. 150 divided by 15 equals 10. So again, these are grouped together in the numerator and the denominator are grouped together. Like the numerator is grouped together and then the denominator is grouped together. So you need to perform them like they're essentially like there were parentheses around the top and parentheses around the bottom. Okay. All right. I did multiplication here first, and then I did the subtraction because that was all grouped together, and then I did the exponent on the bottom, and then I did the subtraction, and then I did the final division because it's 150 divided by 15, which gives us our 10. Okay. All right. On these, be careful because if you need to square a negative, if the negative is in parentheses, that equals a positive. So because negative 4 times negative 4 equals positive 16. If the negative is on the outside, the exponent only applies to the 4. So that would be negative 4 times 4, which is negative 16. So please just be careful with that. All right, y'all. Thank you for being patient with me. I hope I feel better and can see y'all on Wednesday or next class meeting, depending on what class this is. If you have any questions, please reach out to me via email and I will get back to you. Thank you so much. Have a great day. Bye.